Hello, in this video I'm going to show you how to set up Developers Hub real-time networking package. Using this package, you can connect your Unity project to a dedicated server with TCP and UDP, and then you can create multiplayer games with this networking system. So to start, I'm going to create a new Unity project. So there are two packages that you need to download. The first one is the Unity client project, and the second one is a Visual Studio C# console application, which is going to be used as the server. So to download Unity client project, you can either go to the GitHub page or you can download it at the Unity Asset Store. I'm going to put the links in the description. For now, let's just download it from GitHub. Let's go to the repositories and Unity Real-Time Networking Client. I'm going to go to the releases and download the last version available. For now it's version 1. I'm just going to download the Unity package project. Now I'm simply going to import the project. That's it for the client side. So to set up the server side, you need to go to repositories again. And this time you should download Unity Real-Time Networking Server. Of course, I'm gonna use this computer both as client and the server, but you can use a separate computer as a dedicated server to run your server project on it. So again, I'm gonna go to releases and download the last release available. Okay, the downloaded file is on my desktop. I'm just going to extract it here. As I mentioned before, the server project is a C# console application. You need to have Visual Studio installed to be able to open this project. You can simply open the server project by double-clicking on Realtime Networking Server.sln. So let's expand this. You are more than welcome to check out the scripts, but if you don't want to bother yourself with that, let me just say all you have to do is open this terminal script. Everything you need is inside this terminal. So first of all, let's connect the Unity project to the server console. So once your server is ready, you can just start the Visual Studio project. And if you encountered any security alerts, make sure you allow access. Now let's take a look at this terminal script and the connection region. Here there is a max number of players and a port number. Before you start the server, you can change those values. But now let's go to the client. To change the settings of your connection, first you go to Developers Hub tab, then Real-Time Networking, then Settings. There are two values you need to change. The first one is the IP of your server and the second one is the port number. Because I'm using the local machine as both server and client, my IP address is going to be 127.0.0.1, and as you can see here the port number is 5555 on the server, so I'm gonna set the port number on the client as 555 as well. Of course you can change this number, but make sure both server and the client have the same number as port number. So let's go to the demo scene for now. As you can see, this is an empty scene just with a demo script. Let's start the project. If we check the logs, a log has been printed, connected to server successfully, and server time has also been printed. And if we go to the console application, which is our server, you'll notice an incoming connection from this IP address and a couple of messages has been printed as well. So that's how you set up your client and server projects. But now let's start with the basics and learn how to send messages between server and clients. First, let me close both server and the client. Let me start by the server. There are three regions in the terminal script. The first one is update, the second one is connection, and the third one is data. The connection region we explained before. There are two variables, as I mentioned before, you can set those. But there are also two methods, and I think their name is easily explains what is their job. So whenever any client connects to the server, on client connected is going to be called. And you can write down any codes here to handle the situation. There is an ID of that client will be returned. This ID is an index which determines the position of that client in the client's array. The second variable is the IP address of that client. Same thing happens on client disconnected. Whenever a client disconnects from the server, this event will be called. And again, the ID and IP of that client will be passed to you. So that's for connection. There is an update function here. So sometimes you want to process something on the server. Let me say first that this update has nothing to do with the update function in the Unity. It's just a completely separate and different update. This is a server update. So you can determine a number here, for example 30 or 60 or any number, and this update will be called that many times every second. So if you put it on 30, this update is going to be called 30 times per second. You might not need to use this, but it's an option available for you just in case you want to use it. The third region is data. So you can send and receive data between your server and client. There are a few methods here that are going to be called whenever a package from the client will be received. For example, if the client is sending a packet type, you'll get it from here. If the client is sending a byte array, you'll get it here, and the same thing here as a string. There is integer, float, boolean, vector tree, quaternion, long, short, byte. An event, just in case there is no variable and client just sending to notify server about something. There are some examples here in the receive packet and receive a string. You can remove this, and this is just here as an example. Let me actually remove them. So every data sent from your clients will be received here. You'll get an integer as the client ID. So now let's go to the client side. I'm just going to create an empty scene here. And a new script. Now I'm going to attach the test script to an empty game object in the scene to make sure there is a reference in the scene. Now I'm going to open the test script, and whenever you want to connect your Unity project to your server, first let's add the namespace. And in the start or awake method, you can add the proper listeners. To do that, we're gonna say real-time networking. And as you can see, there are a bunch of callbacks here you can start listening to. On connecting to server result, on disconnected from server, these two methods is for the connection. The other ones is to receive variables from the server. So let's say whenever we try to connect the server, we either successfully get connected or we fail to connect. This event is for that. On connecting to server result, let's select that. Now I'm gonna say plus equals and hit the tab key twice. Of course, this works in the Visual Studio. It's just gonna generate a class for me. I can just rename this. And let's get rid of this throw new system whatever. And now whenever we try to connect a server, this method is going to be called. And to attempt to try to connect to the server, we're just going to say real-time networking dot connect. That's all we need to do. It's just gonna attempt to connect to the server and is going to pass the result to this function for us. Let's actually do a debug.log. So now let's check the result and see how this works. First, let's go to the server and start the server. Now let's go to the client and play our new scene. As you can see, a log has been printed. Hello, I am connected to server. Of course, I was sure the connection is going to happen. That's why I didn't check to see if this successful boolean is true or false. But you need to check that too. If the boolean is false, it means the connection was failed and the attempt to connect to the server was not successful. Now I've added another debug log that says failed to connect to server if the successful boolean is false. Let's check this one more time. I'm gonna start the client. The same message, hello, I am connected to server, is printed. Now I'm gonna stop the client. This time I'm gonna close the server. So now the server is down. Let's try again. This time failed to connect the server. So that's how you can manage your connection. So to send packages to your server, you can use sender. You can send any type of package by simply say sender. Then you can either send the package using TCP or you can send it using UDP. So whenever you want reliability, you use TCP. And whenever you don't care about reliability and you want speed, you use UDP. For example, whenever you want to sync the position and rotation, that's best to use UDP. So for now, let's just use TCP send, and I'm going to open the parentheses. As you can see, there are a bunch of ways you can do that. You can either send a packet ID. This is for event. So basically everything except the packet type has an ID. This ID is to identify the package, and it's up to you which ID you want to send. It's completely up to you. Any number you can send as an ID. For example, you send a boolean. You send a bunch of booleans over time to your server, and you want to process these booleans on the server side. So whenever the ID is, let's say, 1, you know this boolean means something and it's 2. And whenever the package ID is 2, this boolean means something else. That's just to identify the value of this variable. What is this value for? That's why you use ID. Just for now, I'm just going to send in a string. I'm just going to use 1 as the package ID, and I'm going to send in a string saying this is the client. That's it. Simply just like that, you can send any packages to your server. And how your server is going to receive that package, as I mentioned before, in the terminal script. So this is a string package, which means it will be received on your terminal script in the received string. So this is where you're gonna receive that package. The package ID here is this ID that I've chosen. I've chosen 1, and this string value also is the value you will receive here. So let's say if my package ID equals to 1, it means that I received this package. So let's actually use console.writeLine to write what we received. I'm just gonna start the server. Now let's start the client as well. Hello, I am connected to the server, and let's check out the log. Server started on that, incoming connection from this, and this is the client. This is the message that we send to the server from our client. Now let's say we want to send a message from the server to the client. In that case, you can simply, let's actually go to the terminal. And let's say whenever you received a package with ID of 1, you wanna give a response to the client. To do that, we're gonna do exactly we did on the client. We use sender class. Send here, as you can see, there are more options available for you. You can either send to a single client, you can send to all clients, you can send to all clients except one. And you can do it in TCP or UDP. Now let's just say we're just gonna send it to one client, and that client we have the ID for it because on the receive string the ID of that client has been passed to us. We can simply use that ID and we can choose a package ID and a value for our package. So let's say we want to say this package has an ID of 3 or any number you want, doesn't really matter. And let's say I'm just gonna send a float. Let's say I'm gonna send 86.145, whatever. So whenever I receive a string and the packet ID of that string is 1, then I'm gonna send a float to the client who sent me that packet. Now let's go to the client side. So as I mentioned before, you can add listeners to receive any type of variables you want from the server. So if you expect to receive a float, which we have here, I'm just gonna go to a start, and in the real-time networking, I'm gonna add a new listener to on float received. So whenever the server sends us a float, we can receive it using this. Let me get rid of that, and I'm gonna rename this to float received. Of course, the best way to do this is to put this on enabled. Let's actually do that. And then we can remove them on disable. I'm gonna add the listener on enable, and I'm gonna remove the listener, as you can see here, in the on disable. Also, we can just remove the on connect listener whenever we receive an answer to our connection attempt. So when we receive a float, let's actually just debug the float. I'm gonna print both ID and value, and let's just put the separator between them. So let's start by server. Server is started. Now the client. As you can see, first it says, hello, I am connected to the server. Then it will send a string. As you can see, hello, I'm connected to the server. Then it will send a string to the server. The server received that string here on received string on the terminal. And then after it received that string, it's gonna send back a package to that client, and the package is containing a float. Also, as you can see, here is the float has been printed for us. And basically that's how you can send packages between server and client. Now there is one thing remains to talk about, and it's packet type. As we said before, we can send strings, booleans, floats, anything. But let's say we want to send a bunch of variables together. For that purpose, we use packet. Let's actually send a packet instead of a string here on the client side. So instead of sending a string saying this is a client whenever we connect to the server, let me remove that. I'm just gonna create a new packet. I'm gonna say packet equals to new packet. And that's it. Then we say sender dot send. You can use either TCP or UDP. Let's actually do UDP for a change. It doesn't really matter. And then we can just simply send the packet. Notice that you don't have a pass-in ID because it's up to you. You can just add an integer to the packet to identify the contents of this packet. It's up to you. So this is important. Now you can add values to this packet. So the values can be anything. Let's actually try to add an integer. We're gonna use packet.write and we say 1, 2, 3, whatever. That's the integer we're passing. Let's actually add an vector 3, for example. New vector 3. One thing you need to be very careful, the order that you are writing these variables. In the same order, you need to read them on the server. So if you write the integer first, this 1, 2, 3, on the server side, you need to read an integer first. Then you can read a vector 3. And after that, you can read a string. In the same order, you have to do it. Otherwise, you'll get an error. So now, let's go to the server side and start listening for this packet and learn how to handle it. So let me close this first. Let's go back to the terminal. And as you can see, receive string is no longer going to be called because the type of the package we are sending is packet. So it will be received here on received packet method. So as I mentioned before, we need to read it in the same order. The first one was an integer. We're gonna say packet dot read integer. The second one was a vector 3. So the same order, we're gonna say vector 3 and we're gonna say read vector 3. And the last one was in a string. Now let's write them in the console to see if the values really match. And I'm gonna just separate the values. Let's start. Now let's go to the client as well. As you can see, 1, 2, 3, and this is the vector 3 and the string. If you didn't receive this, then it's probably because you used UDP and you should use TCP. We close this and let's go to my script here. If you didn't receive the package on the server, make sure you to use TCP. It's more reliable, as I mentioned. So basically that's how you can connect your Unity project to a dedicated server using TCP and UDP. If you had any more questions, feel free to ask me. Thank you for watching.